Hello everyone. Enumerated types, often called enumerations or enums, are a special kind of class used to represent a fixed number of constant values. Simple enums. To declare a simple enumerated type, use the enum keyword and list the values you want to enumerate. For example, enum color, red, green, blue, enum direction, east, west, north, south, enum number of days, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So set of values. We have a code. Let's see, understand from code point of view. So I have a enum which is motivation. It contains two value, money and happiness. I have a enum hobby which contains swimming, skating, traveling, cycling and trekking. I have a person class with variables name, hobby, motivation. Default value of name is empty. Default value of hobby is cycling. Default value of motivation is happiness. I have a constructor which is person. It have three parameters: name, hobby, and motivation. And this is how we are initializing the instance variable list.name equal to motivation equal to person. Here is the main function. Here we are creating the object of person P and passing three parameters: alloc, swimming as a hobby, and happiness as a motivation. We are printing it p.hobby.name. You can see it is printing swimming. Print p.motivation.name. It is printing happiness and name. So it is alloc. Here is the use case that how can we get the or basically traverse through the cases. So uh, if you have this switch which is hobby or hobby is a enum. So if it's a enum, we can definitely use the cases. So if the case is swimming, printing it and break. Case is skating, printing it and break. In the similar way for hobby, traveling, hobby cycling and hobby trekking. Abstract methods. Instance, getter and setter methods can be abstract, defining an interface but leaving its implementation up to other class. We have a code. Let's see the code. So we have a abstract class. Keyword is abstract. You have to use class. This is the name of the abstract class. This is a function and you have to see, notice it. There is no body. There is no body in the function. So the implementing classes will have to provide a body. For example, here you can see. So the class effective doer extends doer because we are extending it. And suppose I comment out this code. You will see it gives the error. We have to provide the body of this do something. So let's uncomment the code, run it, and you can see. So this is the abstract class. This is the class which is implementing it. And from main, we are getting the object of effective doer. We are writing code.do something. And this is the output. Extension methods. Extension methods are a way to add functionality to existing libraries. You might use extension methods without even knowing it, or for example, when you use code completion in an IDE, it suggests extension methods alongside regular methods. We have a code. Let's see. So we are creating a extension and the name of the extension is number parsing. We are creating the extension on string. That's why we are using the keyword on. So keyword extension, name of the extension. It can be anything A, B, C, D, whatever makes sense. On string or integer or float or your custom types. So we can have extensions. Okay. I have created a function here. This function returns integer. The name of the function is parse int and we are saying return int dot parse int. Parse int. What is this? This is the instance of the string. So for example, if you look at the use case, print 42, this is a string, dot parse int. So we are passing 42 as a parameter. So this becomes this 42. So the integer value is 42. In the similar way, we have square it. It is also returning an integer. So in a single extension, you can have, because this is the extension on string, so you can create as many as extension functions on the type, means either on string type or on integer, float, your custom types. Square it. So here again the same thing. Get the integer value and then I want to square. So I said return num into num. So it gives 42 into 42. You get the 1764. Type def. A type alias, often called a type def because it's declared with the keyword type def, is a concise way to refer to a type. Here is an example of type def declaring and using a type alias named int list. Let's go through the code. So this is what is a type list int. On the left hand side, we are aliasing it. We are just giving it a nickname, nothing else. We are just giving a different name. That's it. It is still a list int. Type def int list equal to list integer. And here is the use case. So this is the type int list, which is eventually a list int equal to 123, printing this, and we can see the output. So you can just give your own names to the type. Someone, suppose you have a class, the name of the class is some person which does not look good, but suppose this is the case and you don't like this. You want to give your own name, typed f person equal to some person. This one. So this is not an initialization or something. See, semicolon. We are not initializing it. We are just saying that the typed f definition of this is this. And now if you want to use this, you can still use it. See, so you can say person p equal to person. It should still work. Yeah. Functions. Dart is a true object oriented language. So even functions are objects and have a type comma function. This means that functions can be assigned to variables or passed as arguments to other functions. You can also call an instance of a Dart class as if it were a function. Let's look at the code. Bool, this is the return type. Is Nobel, this is the name of the function. Int atomic number, int is the type of the input parameter. The name of the parameter is atomic number. This curly braces is the body of your function, returning true because the return type is Boolean. Although effective Dart recommends type annotations for the public APIs, the functions still work if you omit the types. So if you can see there is no return type, so that becomes the dynamic return type. Is Noble is the name of the function. Atomic number is the parameter. However, we have omit the type annotations. Type annotations means this thing, int bool, you can see. So we have removed. So this is also possible. You can also write this code, returning false. Arrow functions. So bool is Noble, input parameters, type, name, and just a single line which is false. So this arrow works similar to this. So instead of putting the curly braces, we can also put the arrow and write the body of the functions. And we also say that arrow functions. The arrow expression syntax is a shorthand for curly braces. You return type expression closing of the bracket. The arrow notation is sometimes referred to as an arrow syntax. Functions as a first class object. You can pass a function as a parameter to another function. For example, so let's see the code. So we have a function here, print element. It takes a parameter. This is the body, which prints the element. Here we have a list, and on the list we are calling for each, and we are passing the function. Pass print element as a parameter, you can see. And the output is 1, 2, 3. Functions as first class objects. You can also assign a function to a variable such as, here is the example. I have already the example set up here. So we are creating a function, variable function. This is a variable which is referring to this function. This function have a return type, which is of type integer. Parameter name is a. This is the body of the function up to here. In the body, we are returning a into a. And at the last, we have semicolon because this is the entire syntax. We have to put the semicolon. Print a function passing the value 2 because input parameter is 2. 2 into 2 becomes 4. This is the output. Cascade notations. Cascades allow you to make a sequence of operations on the same object. In addition to accessing instance members, you can also call instance methods on the same object. This often saves you the steps of creating a temporary variable and allows you to write more fluid code. This is the code. Let's go to the code. So you can see we have a class person. Here is name. Here is the social security number. This is the default value. And here we are initializing the, here is the example of using it. So I should say, suppose person. So I'm creating the person object. Pen does not make any sense. So, and then you can notice there is no semicolon. And after that, we are writing dot 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 dot. So that means person dot name equal to all person dot social security number equal to 123. This is what it means. And if we print it, basically run it and see the outputs, you can see it is same allo 123. Lexical scope. Dart is a lexically scoped language, which means that the scope of variable is determined statically, simple by the layout of the code. What does that mean? That means as we move downwards to the latest variable declaration, the variable value will depend on the innermost scope in which the variable is present. For example, you can see this example. So we have this main method. We have a variable language. So the scope of the language is in the outermost uh, body. This is the method now, and now we have changed the language to Hindi. And now if you print this dollar language, it will just print Hindi. Suppose you create it at the global level where language equal to ENG, and now there are, this is the global scope. This the scope of this language is within the body, and the scope of this language is within the body of this function. So the scope is changing. This is what is the lexical scope. Testing functions for equality. So here is an example of testing top level functions, static methods and instance methods for equality. So I have the code base already set up here. So we have a class A with static function, return type is void, and the name of the function is bar. Here we have a function return type void and it is bars. We are creating an object basically declaring a variable x of type function. We are saying x equal to foo, so x equal to foo, x equal to foo. It means now x is pointing to foo. It means x and foo are same. If you run it, you will see the first print is true. Now we are saying x equal to a dot bar. What is a? A is a class. Bar is a static method, so we can directly access it. So x equal to a dot bar. And now we are saying a dot bar equal to x. Yes, definitely. That's what we just do here, line number 14. So if you again print on line number 15, it will again print true. Now we have a variable v, x, v and x, v and w. So v is an instance of a, w is an instance of a. So both of them are different instances. Fine. Y is equal to w. So we said, okay, y equal to w. So we have created a new variable y and we have assigned w. So now basically it is like v, basically w and y both are same. Okay. So what is w? W dot bodge. Okay. And what is x? X was already okay, x equal to w dot bodge. Now printing y dot bodge. Y dot bodge. Y dot bodge is this equal to x. X equal to w dot bodge. And w dot bodge means y dot bodge. So we can understand this is true. Y dot bodge is also referring to the same which x is also referring to. So this is true. Sorry. Print v dot bar. So v is a different instance, w is a different instance. So both v and w are different instances. It means if we print them, it will be false. That's the same thing is happening here. As and is operator. Okay, so we have the code for that. So suppose we have a class person which have a function foo, it prints foo. We have a class employee, nothing is here. We have a top level function, maybe I don't know, are we using it or not? We have a variable p of type person. We have a variable e of type employee. If p is person, this is a use case of using the is operator. If p is person, then print true. And that's what is happening here. If e is a person, print true, otherwise false. So e is not a person, e is an employee. So this is false. That means else will execute. A dynamic declaration. So dynamic p1 equal to person, p1 dot foo, and p1 as person. So because this is a dynamic declaration of p1, so we are typecasting it from dynamic p1 to concrete class, which is person. So p1 as person dot foo. So you can see the magic. If you typecast it and if you then you write dot foo, you can see the autocomplete. And if you don't typecast, you will not get the autocomplete. See, p1 dot, it is not showing you dot foo. So even if at the compile time it will work, that is fine. But the time when you are writing the code at the compile time, this is better because it will just work. So p1.foo, it prints foo, and you can see the output. Both are working. One uh, is much more readable, and when you write the code as a developer, it makes a lot more sense. This is dynamic. This is just working. Assert during development, use an assert statement. Assert condition optional message to disrupt normal execution of a Boolean condition is false. You can find examples of assert statement. Okay, let's see. So here is an example of the assert. So where number equal to 100, assert number is less than 100. So 100 is not less than 100, 100 is equal to 100. That's why it will assert and your script will not run. You will get the script error. Type introspections. In computing, type introspection is the ability of a program to examine to examine the type of properties of an object at runtime. Some programming languages possesses this capability. So we can see from the example, so A equal to 100, print the type of A is $A dot runtime type, and you can see it is integer. This is the introspection. This is the inspection of the type of A. You can see it. Getters and setters are special methods that provide read and write access to an object's properties. For example, we have the code base. So we should have the code base. Okay, no problem. So we have a class rectangle and it have the member variables like double left, top, width, right. This is the constructor, rectangle, left, top, width, height, all the variables. Here we are creating a getter, which is double, returns a double, get, and the name of the getter is right. The body is left plus width, and this is the setter, which is right, and we are passing a double value, and the body and the logic is left equal to value minus width. So if you want to get the right point, you have to get left plus the width of the rectangle. So you will automatically reach to the right. And if you want to set the right, so whatever value you will pass based on the right values, the left will be in the received value minus whatever is the width of the rectangle. So we can see also this code by copy pasting and running it. So you can see here. So print rect dot left, that is 3. Print rect dot right, left plus width, that becomes 20 plus 3. It becomes 23. Thank you so much.